So in the last video, we looked at something called bootstrapping. It's a recursive process where we use price information about bonds, about coupon bonds, to extract the yield curve. Sometimes we don't have enough information to do bootstrapping. Notice we needed one bond for each of the different periods for which we wanted a spot rate. Right? In the following example, we're not going to have enough information, but we'll have enough to solve the problem. It's from Broverman. It's a nice problem. I really like it because it illustrates the creation of something called a synthetic transaction. So let's go through the problem, then I'll explain the strategy, and then we'll walk through it. So we're given the following information about two 10-year bonds. Both bonds have face amount of 100. Coupons are payable semi-annually with the next coupon due in a half a year, meaning we're about to, we're starting at time zero. Bond 1 has a coupon rate of 4% per year. Remember, semi-annual, so that's really a 2% semi-annual rate. The price is $85.12. Bond 2 is a coupon rate at 10% per year with a price of $133.34. We need to find the yield rate for a 10-year zero coupon bond. So the problem here is we would need something for at least every year, if not every half year, in order to do bootstrapping, because we have to start from the very first spot rate and build our way up recursively. We don't have nearly that much information here. However, we have enough information to create what I call, what would be called a synthetic zero coupon bond. What a synthetic X is you generate the cash flows of X by buying and selling stuff, some combination that results in the same cash flows. That's the basic idea. So our task is to buy and sell combination of bonds 1 and 2 so that our cash flow starts with us spending something at time 0 and getting a redemption at time 10 with no cash payments in between. Now we could set it up so that we pay at time 0 and pay again we collect at time 0 and pay the redemption at time 10. It doesn't matter, it works either way. One is a selling position, sometimes called a short position, and the other is a purchasing position, sometimes called a long position. But in this case, it doesn't really matter because we're just after the interest rate. All right? So the whole idea is to basically buy a combination of these that cancels out the coupon payments. So let's begin and look at the details. So we're going to first describe the cash flows for each coupon bond. So for bond 1, assuming we're buying, we spend $85.12 today. What we get is, remember, these are 10-year bonds, and so we get 20 semi-annual payments of 2. Remember, the coupon rate's now cut in half. And the final payment is accompanied by a redemption of 100. For the second bond, we pay $133.34 today. We have 20 semi-annual payments of 5. Remember, it's half of this, followed with the final payment accompanied by a redemption of 100. So what does that mean? What we want is we want to pay something now and get a single lump sum in 10 years, which is after these 20 semi-annual payments. So we want to buy and sell a combination of these two bonds so that the total coupon payments being some multiple of 2 and the total coupon payments for bond 2 being a multiple of 5 cancel each other out. That's the strategy. And that's what the intro to part B says. We'd like to construct a transaction involving buying some of one bond and selling some of the other, so we have a net cash flow of 0 until maturity, creating a synthetic zero coupon bond. Or as I'm enjoyed calling it when I wrote this, zeroing out the coupon payments. So let's figure out what we'd buy and what we'd sell. So we notice 2 and 5 are not multiples of each other. So we buy a multiple of the 2 and a different multiple of the 5. Well, the natural thing to do is buy 5 of the 2 and sell 2 of the 5. Right? Buy 5 of the first bond, that means we receive a coupon of 10. Sell 2 of the second, we owe coupons of 10. Now, when it says we're vice versa here, that means we could sell 5 of the first and buy 2 of the second. But it's always 5 of the first, 2 of the second. One we buy, one we sell. And which one we buy and which one we sell just depends on whether we have a long position or a short position at the end of the day. And for our purposes, we don't care because either allows us to calculate the exact same interest rate. So we're going to stick with buying 5 of the first and selling 2 of the second. So what's the net cash flow? Right? So today, if we buy 5 of the first bond, that means we paid 5 times 85.12. So that's where this 426 comes from. We sell 2 of the second bond. That means we collect 2 times 133.34. So that means we receive 266.68. So that's a net cash flow that we pay of 158.92. So we're buying this thing, so we have a long position. Right? If you reverse the purchase and sale, you'd have net cash flow of negative 158.92 that you would receive. Right? But anyhow, we pay 158.92 today. Every 6 months until maturity, we receive 10 from bond 1, pay 10 for bond 2, resulting in a net cash flow of 0. Well, that's exactly why we did this, right? So there's no surprises there. Finally, at maturity, we bought 5 of the first bond, so we get 500 from bond 1, but we sold 2 of the second, so we have to pay out 200 for a net cash flow of 300. So, bottom line, we pay 158.92 today and get 310 years. We have effectively synthesized a 0 coupon bond. All that we need now to do is find the corresponding interest rate, and now we've got our spot rate, the one that's desired. So we solve this equation. 158.92 should be the present value of 300 with our spot rate S10. And we find that S10 and we get 6.56%. Is that our answer? Or did I screw it up? Numerically, it's correct. Yield rate for a 10-year 0 coupon bond. It does not say quote as a semi-annual rate, so I'm sticking with it. 6.56%. And I think if I checked in the back of Broverman, that was probably the right answer. So we found our spot rate. So what was the strategy? The strategy was to buy and sell some combination of these things so that we had a net cash flow at time 0 and 10 only. And then we equated those in a way that we valued those consistently that in a way that allowed us to solve for the desired rate. In the final video, we're going to look at something that it's not really an average, but can be interpreted as an average of the rates in a yield curve.